Hi there. When you are trying to find the general solution of a second order differential equation, it kind of matters what the differential equation looks like. So if your differential equation looks something like this, which it would in a general form, it's important to notice how we can rewrite that equation. So notice we have second derivative plus some number times the first derivative plus some number times the original function equals 0. You can rewrite that as a quadratic. Notice that this equation has no derivatives in it at all. We've just replaced the second derivative with k squared. We've replaced the first derivative with just a k. We've left the numbers intact. If those numbers, when you solve the quadratic, you end up so that your discriminant is greater than 0. So that's thinking about quadratic formula there. If you do your quadratic formula and you come out with solutions, or if you're able to actually factor the quadratic and come up with solutions, then you know that your equation is going to follow your actual solution is going to follow this pattern. So again, let me say that again. If you're quadratic, you can solve it by factoring or quadratic formula where you produce real solutions, not imaginary ones. You produce real solutions, then your solution is going to follow this pattern where the solutions become multiplied times x in your exponents. So k1 here being a solution of this quadratic, k2 being a solution of this quadratic. Now let's flesh this out with an example here. I've got second derivative minus 6 times first derivative plus 5 times the original equation. Now we're going to rewrite this differential equation as a quadratic first. So you'll notice I've replaced second derivative with k squared. I've replaced first derivative with just a k, and I've eliminated the y altogether. So we're going to solve this equation. You can do it by factoring or quadratic formula. Either one works. I'm going to lean towards factoring. It's a little bit faster for me. And there I get that my two solutions are 1 and 5. Now, because I got two real solutions, I know that my solution to the differential equation is going to follow this pattern. C1 and C2 are simply constants. They're going to remain in our final answer. However, we put in we substitute in that 1 for K1, we substitute in 5 for K2, and that's how we come out with our general solution here. I hope that helps.